Okay, moving on to algebra transposition. Also known as rearranging. You've done this at school or whatever, make X the subject of, and you know, that kind of thing. This is a wonderful skill. It's like a building block of mathematics. If this was an English class, to be able to construct paragraphs, you need to know where to put full stops or periods or commas, quotation marks, that kind of thing. In mathematics, you need transposition skills in rearranging formulas to really understand how the whole thing works, because this is used in almost every branch of mathematics. You might have come across something called BODMAS or BIDMAS, which is the order in which to work equations out so that you get the same answer as everybody else working it out. That's a skill that applies to all of mathematics. Transposition is a skill that applies to most branches of mathematics. Let's have a quick look, because it's not actually too difficult. Let's say you've got £10 and somebody gives you £2 in currency. That obviously gives you £12. Now when you're rearranging formulas, something magical happens when you take terms over past the equals sign. And what happens is the symbol that's attached to the term reverses, right? So it does the opposite. So the opposite of plus is minus, right? Let's just capture that. The opposite of plus is minus, the opposite of times is divide, the opposite of square is square root. At this level, that's about all you need to worry about. 6 symbols, right? There's 26 letters in the English alphabet, so 6 symbols isn't much to learn. Okay, in this case, 10 plus 2 equals 12. If we rearrange that, if we take plus 2 across, it's going to become minus 2. So we end up with 10 equals 12 minus 2. Is that a true statement? Well, 10 does equal 12 minus 2. That's true. 10 plus 2 is 12. You could also, if you like, 10 add 2, let's rewrite it another way around. 10 plus 2 equals 12. You could say 2 plus 10 equals 12. It's the same difference. You could take plus 10 across, oops, and you'd end up with 2 equals 12 minus 10. You see how that's changed to a minus? So if it was 2 times 10 equals 20, take times 10 across, you'd end up with 2 equals 20 divided by 10, which is perfectly true. So rearranging stuff's not that difficult, providing you remember to change the symbol, to change the polarity of the symbol once it goes over to the other side. Now what people tend to do, of course, in mathematics, if you're dealing with numbers that can change with variables, then of course that's where algebra comes in. So if you've got £10 and someone comes along and gives you a certain amount of money, they might give you £2, they might give you £15, they might give you nothing. That symbol that amount could change. So for instance, you might start off with a certain amount of money in your pocket. Someone comes along and gives you another amount of money, and that equals the total amount of money that you'd have. That's fairly straightforward. We're just copying what this says. Now, let's say we want to rearrange this formula. We want to make A the subject. We want to work out how much you had originally, or somebody else had originally, knowing the other 2 variables. Well, to get A on its own, all we have to do is remove plus B, and we're finished. So plus B goes across, which leaves you A equals C minus B. You can't do any more than that. That's the end of it. There are no numbers in this equation, so that's it solved. Alright, fair enough. Let's have a look at something more complex then. Let's say you've got 2A plus B equals C. Now, we want to get A on its own, so again we'll make A the subject. Well, the easiest term to get rid of, the weakest term if you like, is this plus B. We can get rid of that and 2a, you should already know this, but whenever you see things together, mathematicians can't even be bothered to write a times sign. 2a is the same as 2 times a, right? So when you see things like ab, it means a times b, right? So mathematicians can't be bothered to write a times sign, right? So it's no wonder algebra's prevalent. So we'll get rid of the plus b, and then we'll get rid of this 2. So we're going to have to do 2 stages to this equation to solve it. So get rid of plus b, what's that going to become? Minus b. So you're going to get 2a equals c minus b. Nearly there, we've got to get rid of this 2. Well, 2 times a, if you take times across, it becomes divide. So you end up with a equals, and because this is already there, the divide to applies to everything that's there. So it's not a equals c over 2 minus b, no. C minus b is already there when you take that over, so all of that gets divided by 2. Okay? Let's do circumference of a circle equals pi times diameter. Alright, let's rearrange this then for just the diameter. Well, that's pi times d, so if you take times across, you end up with c divided by pi equals the diameter. Okay, that's a fairly straightforward one. I'm just trying to get the point across. A squared plus b equals c. Get rid of the plus b first. So a squared equals c minus b. And then the opposite of square root is square is square root. So you end up with a equals, that's all already there, so all that gets square rooted. Right? It's as straightforward as that, really. You've just got to attack it in chunks, and you'll be all right. Now, the only thing to remember, really, other than that, is if you see any terms that are similar, like 6a plus 3a equals b, group the terms together that are the same. So 6a plus 3a is the same as saying 9a equals b. So rearranging for a on its own, well, 9 times a, take 9 times across, a equals b divided by 9. So don't worry if you're not told where these formulas come from, just practice the skill of rearranging them. So treat it like Sudoku in a newspaper. It's a puzzle to be solved rather than something to worry about. Don't worry about where formulas come from. That's like worrying why trees are green. Just accept it. Right? That's the easiest way to do it. I'll put some questions up for you to pause on screen, and I'll put the answers to these up as well. Thank you.